So this project is about trying to reduce the adverse effects of disasters after they have occurred. After a detailed literature review, we found that a lot of the deaths and damage in a disaster occurs due to miscoordination among the rescue services. Also, many people who are in need are unable to communicate their location, either due to being injured or being separated from their loved ones. Thus, we tried to make an app which will help solve some of these problems. So, our general idea is that we want to improve coordination between rescue services by providing them a unified platform where each can know about the movements of the others, and our algorithm shall compute an optimal trajectory for each of them considering all of the others' movements as well, which shall help in proper distribution of resources. Also, since the location of people shall be communicated by the app continuously to the server whenever there is a warning and a disaster occurs, so we shall be able to locate them easily and optimize distribution of resources.
Hello everyone, this is the app demonstration video, and in this video I'll be demonstrating both the user and the rescuer app. So first of all, we see the user app. So the app named BeSafe is the user app. So we open this first and we see that it's a very minimalistic application, and in the background you can see the logs of the application, so we know what's happening in the background. We'll use that in the later part of this video. The reason this app is very minimalistic is because in the time of disaster the user is in the state of panic and won't be having any time to use the app. So when the user opens the app, he just has to register himself using this button, and so we are taking name, age, gender, and whether the person is disabled or not. This information is required because we are setting the priority of the user in the case of disaster. For example, prioritizing the disabled people first, then females, and then the males. So we just enter some values. There we go. So our first user is registered, and as we can see, he will be stored in our backend table, which is saved on Azure. We refresh this table. Yeah, and we can see that we have been registered. Now the user can simply close the app, and the app will run in the background listening for any disaster warnings. Now we'll demonstrate what happens in case of disaster warning. We simulate this by sending a warning using a Python script. So we'll run the script which sends a disaster warning to the user. So here we can see the app has sent a warning which has been received by the user in the notification tray. There it is. The user don't have to do anything. The app automatically starts sending the location of the user in the background, which we can see in our log table, these values, and also this location is stored in our backend table. We need to refresh this. Now we can see that our location is stored in the table. Now we are done with the user app. Next we'll move on to the rescuer app. Hello everyone. In this video we'll see the working of our algorithms. So all algorithm files are stored in the folder named algos. Here The main file that I'll be demonstrating is this plan and send.py. So at this point we have the location of our rescuers and our victims. What we need to do is convert all the victims into certain hotspots, which means the places where the density of victims is more. Then we match every rescuer to every hotspot and send the action plan to all the rescuers, which they have to follow. So how we do this is we first query the SQL database. Here we can see the query for fetching the data of the victims, and we store the data. Similarly, we store the data for the rescuers. Next, we compute the action plan. So this line over here gives us the action plan, and then this chunk of code sends the action plan to the rescuers.
Now we will cover the Rescuers app. We have named Rescuers app as Disaster Heroes. The very first thing the rescuer will have to do is fill a registration form. Here he can name his service, and the number of people he can cover, and the type of service. The operational part is used to update whether he is currently operational or not. This information has been sent to the server, which is running on Azure, and this information will be used to calculate the heat maps and where he will have to go. To simulate the problem, we have made a debugging simulate button. It will be removed in the final app. When we press this button, it is populating the database with random location of the victims. Now, on pressing the mark button, it is fetching the heat map generated by our algorithm. And here we can see this is our location. The yellow is all the heat maps are marked in yellow color, and the heat map in which we have to go is marked as pink. Its marker is purple color. We can see the latitude and longitude value of the marker, and once we reach there, we can update the remaining resources by this. Here we can update after a delivery. After a successful delivery, we can update how much resources are left and whether we are operational or our resources has been exhausted. Now, if we have to navigate to a position, we just select the marker and press the navigate button, and then we can navigate to the position. What our algorithm is doing is giving the first action plan. That is the first position he should go. After he has delivered the resource to that position, he can again fetch the next hotspot he should cover.